most of you kind of know me. I was part of the ARM ecosystem for a number of years. I moved over to AWS in October last year. And if I had $1 for every time somebody in the ecosystem said to me, I just spin up instances in the cloud and run stuff, can I do that on ARM? And the answer used to be no. Obviously, there's the Works on ARM program that provides stuff and been doing a great job. And now you also have AWS providing EC2 instances. So we figured it would be good to come along here, run a workshop. We've got one of our solution architects who's local going to be here tomorrow and Thursday, and give you guys an opportunity to play hands-on with some EC2 instances and show you how easy it can be to actually migrate an x86 workload and experiment with that on ARM instances. The key thing I wanted to point out, some prerequisites that you can see on the chart here, of course, have a laptop or whatever, or something with shell access. If you can go and sign up for a free account ahead of time, it'll make things that much smoother because we don't have to deal with that at the start of the session, which will burn time. But not only that, Amazon accounts actually have some security and stuff associated with them, and if you spin up new accounts and then start doing stuff with them, sometimes it gets a little bit funny if all of a sudden a whole bunch of accounts established in Bangkok spin up and start doing stuff. It might think there's something weird going on. So try and do that ahead of time if you can. There's a session as part of the ARM and ARM Day tomorrow, and then there's another session on Thursday. I do have some AWS credits with me that we'll provide at the start of the workshop to folks attending it, so you won't be out of pocket for doing this. And we'll have the solution architect on hand to answer any technical questions, so you don't have to rely on me, which is a good thing. But yeah, if you have any questions ahead of time, track me down. My email address is up here, I think. Anyway, it's just jeffu@amazon.com, so chase me down if you want to talk about it before then. All right, and look forward to seeing you guys tomorrow. Cheers.
All right, thanks a lot, Jeff. Okay, so I think we should talk about just a few amazing facts that we were able to dig up about Thailand. At least I thought these were amazing. So Thailand as a country, it's made up of 67 million people or so. There's actually 1,430 islands that make up the country of Thailand, and there are over 35,000 temples in Thailand. Pretty interesting statistic. I thought it gives us a general sense of where we are this week. And over 15% of the total population lives right here in Bangkok, and that's probably no surprise. Some estimates are as high as over 20%. It's governed by a constitutional monarchy with a parliamentary government, so it's a nice mix of both. I think this is similar to some other countries that we're very familiar with. And the ruling family, the king and the queen, are extremely well respected and highly respected here, and they're very supportive of their monarchy here. And they play an important role in Thai life and Thai society. Thailand's comprised of 77 different provinces. And Thailand is the only country, the only one in Southeast Asia which was never colonized by a European country. So we were sort of discussing this earlier this weekend when we got here about, well, so it's never been English, it must have been French, right? And actually, it's never been any of them. Thailand's always been an independent country throughout its whole history. And Thai itself translated in English into the word free. So the name of the country, Thailand, is the land of the free, which I think is really quite nice. Quite a pleasant translation. And most people know that Thailand used to be known as Siam. And yes, Siamese cats actually also originated from here. It was Siam up until the 30s. It got changed to Thailand in the mid-30s or so. And then it got changed back to Siam. And then eventually, I think around 1947 or 8, it was changed back to Thailand permanently, and it's been Thailand ever since. And one other interesting fact I thought was it's considered good luck to present a bride with a pair of Siamese cats. Like that's one of the best gifts that you can give is a pair of Siamese cats when somebody's about to get married. And also, and this is probably no surprise, the first known pair of Siamese twins were born in Thailand in 1811. They're actually quite famous. I'm pretty sure they're in the Guinness Book of World Records. They were actually married to two sisters, and they had, each one of them had over 10 children. So between the two of them, they had 20 children, and they actually had a bed in their bedroom that could fit 4 people. And of course, that's what they would need, right? So pretty interesting history there. And I also thought it was interesting that Thailand was actually the birthplace of Red Bull in 1987. So this is a drink that most of us are familiar with, and it's actually based on a Thai drink, the name of which I found unpronounceable. But Red Bull, of course, is known worldwide now. It's quite a successful drink. So we do have 2 keynotes today, 2 folks that have traveled quite a distance to be here. The first is Zane Wei, a senior director from Huawei from the Intelligent Computing Business Unit, and then someone who we're quite familiar with, Tim Bird, who's at Sony Corporation. He's attended many Connects in the past. So, so please join me in welcoming Zane Wei.
Thank you. Okay. Okay. Good morning, everyone. So it's it's a great honor to be here, actually. So today I'm going to share something about actually from Huawei side. Actually, we put a lot of efforts on ARM community. So we want to share some more interesting things, actually, what's going on in our hardware side, particularly in ARM server side. So I'm from Intelligent Business Group, actually, in our company. So first of all, let me take a look at what's going on in computing world, actually. So right now, for computing world, right now already going to the third generation. So from application point of view, actually, right now it's very diversified. You know, it's handling a lot of data, actually, like structural or non-structural data. So so big data, actually, it's kind of key focus for computing 3.0, I mean third generation computing technology. So that's why actually from a computer architecture point of view, actually we need some more heterogeneous computing technology actually. So so then let's take a look at actually in heterogeneous computing actually for why ARM is actually it's one of the choice. So for ARM society, you can see here, till now, actually already ship out from device side, already ship out 120 billion chips. So previously, ARM actually just focused on device side. So from our very old perception, it's very small, it's very power efficiency. So since actually several years ago, since ARM formally announced they are 64-bit architecture actually. So ARM already have the several players actually develop ARM servers. So in data center right now, ARM server actually is getting more and more popular. So particularly in several applications like big data, like storage, like those ARM native applications. So ARM server already shows some big advantage. So you can see here in the past year, some player in ARM community actually, for example, Microsoft. So AWS, they already announced that develop some ARM servers in their data center. So in our previous talk, actually, in Japan, they already developing ARM-based HPC. So at this point, at this moment, you can see ARM already getting more and more momentum. So then let's take a look at our Moore's law. Somebody always say right now from chip level, actually Moore's law right now cannot work. So, but from system point of view, actually the Moore's law is still working actually. So why? So here in computer architecture point of view, they use a kind of heterogeneous computing architecture. So except those kind of general purpose server. So ARM MIPS or power right now, particularly ARM actually right now gradually occupying data center, kind of segments. So the other actually trends actually you can see AI application. It's getting more and more popular. So GPU or NPU or those kind of neural processing units actually right now getting more and more popular. So heterogeneous will help the driving Moore's law working. So from Huawei point of view, so we, based on those application requirements that we take from our long-term strategy, right now we define the three kind of hardware platform to meet those kind of application requirements. The first one, we're still developing our general purpose server based on, for example, based on IA architecture. So second one, actually, we heavily invest on ARM-based architecture. So, as you know, ARM-based server, it's a very power efficiency, it's very green. So we already developed ARM-based chips. Later on, I will introduce more. Then the last one, actually, in order to meet those AI applications, we are developing AI chips. So last year, we already have a formal announcement. We developed two kinds of AI chips. So first one we called Ascend 310. Then in this year, we will formally launch our Ascend 910. So these two chips will help us to build those very power efficient AI applications. So then let's take a look at our ARM processor. So in the beginning of this year, we formally announced our ARM most powerful ARM chip. This one actually is our, I guess actually it's the most powerful ARM processor on Earth. So you can see here from the benchmark testing, so spec 8, it reached over 1,000. So it's used 7 nanometer manufacturing technology. So it's a very high integration. It integrates ROC, SAS controller, SAS bridge, and CPU core inside. So it's a very high density. It can support 64 cores. So for its frequency, it's up to 3.0 gigahertz. So for this processor, so we can build very high throughput I/O capability. So it's very suitable for those big data related kind of application. Due to its lot of core inside, it's very high parallel. So so based on this chip, so we developed several kinds of our servers in data center. You can see here. So powered by our Kunpeng 920 CPU. So we have a 3 category of our servers. So based on different kind of workload, so we have a 2U server, the 4U server, and those are very high density server. So try to meet a different kind of application. So here actually for 2U server, it can meet diversified workloads. So there's 2 sockets inside. So so for I/O bandwidth, you can see here it can support 8 channel memory. So it can support latest PCIe 4.0. So I/O throughput it's a key benefit. It still can support up to for Ethernet. It can support up to 100 gig Ethernet. So I/O throughput it's a key advantage. So for storage, so for one rack, it can support 5.6 petabyte. It's a very high density. So for those applications, it requires very high density computing capability. So we still provide those rack scale servers. So actually, you can see here. So from an application point of view, so from our initial kind of testing, so we think 4 key kind of application is quite very suitable for ARM. So the first one is for big data analysis work. So it requires for those big data analysis workload, it requires very larger, parallel, CPU. Then it needs a very high I/O throughput. So still need very low power consumption. So in last year, actually, for this kind of workload, we already ship out thousands of servers. So for software-defined storage, we think this is a very suitable workload. So we already integrate Ceph actually on top of our ARM servers. So for third one, actually for ARM, those native application, so previously, all devices, those CPU actually, most of them actually use ARM-based processor. So it's very easy to migrate those workloads to ARM servers. So make it actually very, while move from device to ARM, those server or ARM-based cloud, actually, it will, it don't need those extra, for example, performance losses. So it will bring some extra, power efficiency. So those native application is a key benefit. Then HPC. The last one is HPC, actually. So in the previous talk, post-K, they already they developed an ARM-based server. So we think HPC still is one of, particularly those HPC targeting big data processing or AI. So we think ARM actually, it will show some great, advantage. So these four applications, we think actually it will bring some extra, power efficiency option for those applications, particularly use ARM. Okay. So while we move workload from previously, for example, x86-based application, we still have something to do. So here we figure out, for example, for compiler, actually, we need to rebuild compilers. So we need to optimize GNC, previously GCC, to try to adapt to ARM processor. So we need to enhance those labels. So enhance some mathematical labels. So it need to support a vector on some Fortune compiler. So for compiler point of view, actually, it still need a lot of work to do. Then second thing, so for library, particularly in HPC, actually, we need to rebuild MPI stacks. So we cannot reuse previously, for example, x86-based those MPI stacks. So for ARM processor, it needed to tailor-made for ARM processors. So at this point, we have to do something. Then for GDK actually it's a key application. So we still need to do some optimization work. So some basic labels like FFT actually is right now in ARM side, so still need to rebuild actually. So it still need to enhance. So here actually we still need some work to do. So then the last thing we think, if there's a translation layer, it can automatically translate x86 application to ARM. So it will be much better. So here we need to, if we can build a kind of those such automatic translation layer, it will be much better. But actually, at this point, actually, we need to care about more IP issue. We need to solve those IP issues. So that means for ARM processor, if we want to go to very large use space, actually for mass use, actually, we still have a lot of work to do. So for the other, on the other hand, actually, the previously ARM architecture designed for those very small, very lightweight applications. So based on 32-bit, CPU. So right now, move to ARM 64. So that means still need some tools to build. For example, from ARM 32 to ARM 64, if we need a kind of automatic interpolation layer. So make sure those from up-level application, it's hardware agnostic. So at this point, still have a lot of work to do. So then for GPU, so in previous talk already talked about the GPU. So right now, actually, ARM actually there's no very powerful GPU support. So for those rendering applications, so it still needs some accelerator or encoding or decoding components. So at this point, actually, we need to build GPU support. Then the last thing, actually, for virtualization, actually. So as you guys know, for ARM, actually, currently it just can support single threads. So for virtualization, actually, it sometimes require multiple threads. So virtualization work still we need to improve. So to try to to meet those applications in cloud side. So VR mode actually, so we need to try to do a lot of work actually to help to migrate the previous general purpose server to ARM side. So this is from our point of view actually we need some tools. So the other thing actually we think is quite important. It's very imminent. We need to develop developers. So as you know, for x86, there are millions of developers. But right now, actually, for ARM side, ARM community, it's only thousands of developers. So here, actually, we need to put a lot to developers. So this is first thing. Second thing, actually, we need to enable ISV. So just 2 weeks ago, our company we have an announcement in China. So we will. In this year, we will provide at least 1,000 servers to our ISVs. So we still will build an online ARM cloud to provide those kind of test vehicle for our ISVs. So this is actually still need a lot of work to do. Then the last thing, actually, we still need to care more about the students. We need to build. We need to build, students, eventually they will become, after they graduate from university, they will become engineer. So while they are learning actually in the university, we need to tell them how to program on our ARM servers. So here, actually, we already participate. We try to create some programming computation. Actually, we will sponsor them to build those very large student use space. So this three actually developer program actually from our point of view is very important. So then let's go to take a look at our ecosystem work. So in the past year, we put a lot of resources, put a lot of efforts on ecosystem creation. So right now you can see here. All those mainstream operating systems, they already support our ARM servers, like Red Hat, SUSE, Ubuntu, or some China operating system vendor, like Killing. So for virtualization or database, so more and more partners, they already announced to support it. For example, OpenStack, for example, Fusion Sphere, it's our own virtualization layer. So for MySQL, for Redis, for PG, actually, so both of them, all of them already support ARM. So on top of some application, for example, in big data area, we are working with Hortonworks. So we already built a POC. So move their Hadoop-based big data layer to our ARM servers. So we already built a very large, self-based distributed storage, so in China. So for some industrial CAD or CAE tools, like EDO tools, like Cadence Synopsys, so they right now they already migrated their application on ARM servers. So so here actually. From an ecosystem point of view, I'm actually getting more and more attention and getting more and more support. So today, actually, Linaro, we are in a Linaro kind of conference. So I think Linaro can play more bigger role actually in driving ARM-based society. So we try to build an open, collaborative win-win and ecosystem. So each ecosystem still is a very critical part of our ARM community. Okay, so here I give you an example. So we are working with Hedge Gaming Cloud. Use our ARM-based server. We deployed 100 TaiShan server, ARM-based server, to build ARM-based cloud. Then on device side, they already use our Huawei devices. So based on those kind of, from a cloud to device solution, so it brings some extra, advantage. Its performance is 3 times better than previous general purpose server. So it brings very power efficient solution to our customer. So this one actually is we're in ARM-based native cloud application. Okay, so right now I have to wrap up my talk. So as I earlier mentioned, the ARM right now getting more and more momentum in vertical application, particularly right now in some vertical industry. So in last year, actually, we already shipped out over 30,000 ARM servers. So in this year, the shipment will double, at least will double. So ARM actually right now it's getting more and more acceptation by our customers. So the second thing, so ARM-based CPU actually it's now getting more powerful under efforts of all players. So it already gradually changed its previous lightweight perception. It became more heavyweight. So all players actually, from my observation, they are working on. So the third thing, so in order to enhance those use space, we have to do something, particularly in tools, some tools like compile, like labels actually. So we need to do a lot of work to make sure those upper-level application will be more hardware agnostic, so it can help to easily migrate their previous application to ARM. So the last thing, ecosystem still is a critical part for gaining market segments. So we still need to put more resource, put more efforts on creating better ecosystem. So the last very important thing. So in order to getting more and more ARM-based community for a very large user base, so we still need to innovation. So only innovation can change the world. So thank you. That's my talk.
Thank you so much, Zane, for joining us this morning
and
coming. Okay, now we'd like to introduce, please join me in welcoming our good friend, Tim Bird.
Hello, everyone. It's a pleasure to be here in Thailand. This is actually my first time in Thailand, so very happy to be here. And for those of you who, I've been around the Linux community for over 20 years, coming up actually on 25 years. And so I feel, although I don't have a gray beard, I feel like one of the Linux graybeards. And you might not have seen me around the kernel, and that's because I've been switching over to QA stuff in the last couple of years. And so I'm going to talk today about open source QA in particular, and a few ideas that I have, I think, where we can make better progress. Okay, so my clicker is not working. Oh, there we go. So the problem, if you want to call it a problem, we can do much better with Linux QA as an industry and as a community. That's my assertion. Actually, I don't see it so much as a problem as an opportunity. I'm not saying, actually, that we're doing anything wrong, and as I get into the status section of my presentation, I'll tell you about all the great projects that are open source already. But I think as an industry, we're missing opportunities to do even more, and I hope I can kind of explain my thinking on that. Okay, there we go. So I'm going to just go through 4 main topic areas here, the attributes of open source. It's a little bit like preaching to the choir. Most of you kind of understand how open source works, but I'll give you just one slide of talking about that, and then we'll go through the status of open source, some of the obstacles, and then solutions. Okay. I may just have to tell you guys to do it because this isn't working at all. So next slide. So attributes of open source. As you know, open source is openly available to everyone. It's easy to contribute to. And I'm talking here not about the OSI definition of open source, which has to do with the legalities and how a license is framed and that type of thing. But what are the things that actually are kind of the attributes that make it so that something is a successful project? Another key idea is that it's generalized applies to a broad range of uses, and that's important in order to build up a large ecosystem. It has a development community around it, and in particular, there's something that I refer to as the open source effect or the community effect, that people build on the work of each other. And as the contributor pool increases for an open source project, you see a big project like the Linux kernel that has thousands of contributors, better ideas come from that pool of people. It's the Eric Raymond, I think, in his Cathedral in the Bazaar, he said, with enough eyeballs, all bugs are shallow. And that's a weird way of phrasing it, in my opinion. If you have more people, you're more likely to get good ideas out of that pool of people. And you end up getting feedback loops. As people work in collaboration with each other, you really get a community effect where you get the best of breed ideas. And the essence of open source really then boils down to this exchange between people. The sharing of ideas, the sharing of concepts, of implementations, and of work. So let's look at the current status of quality assurance in open source. So there's a lot of different areas. There's the software landscape, but there's also the hardware. And I'll look at it from my perspective in terms of industry QA, what I see as a product developer inside Sony with our open source based products. Primarily, what I've worked with historically at Sony has been TV sets and cameras. And so it's going to have a little bit of a product slant to it. But I think that this is true in all kinds of categories that are using open source software. And the bottom line is I think that there's a lot of stuff that's unshared. Yeah. First, what tools are there in the QA, for QA that are open source already? Actually, there's quite a few. We've got BuildBot, Jenkins, Lava, LKFT, Kernel CI. Several of those projects are founded by Linaro and actively worked on. Fuego is the one I'm working on, which was a Linux Foundation project. I just heard about one, I think it was last week or the week before, called CKI out of Red Hat. But there's lab and board management software. There's lots of different open source tools for that, LabGrid, Slav, libvirt, and R4D. There's test harnesses. There's actually services. I classify 0-day as a service because there's only one lab that I'm aware of that's running the 0-day software, and that's the Intel 0-day service. I don't know, but Phoronix does a whole bunch of benchmark testing, CKI by Red Hat. They also do some testing. And then there's test suites. And in fact, there's a whole bunch of test software. So in terms of kernel testing, you've got the granddaddy of functional testing for the kernel, which is LTP. And that actually consists of multiple test suites. You have a whole bunch of performance and system call tests, sysbench, unit specs, hash specs, drystone. You can go on. You can make a list of 40 or 50 of these, actually. There's system testing that's done by some of the packaging people. Yocto has p-test. Debian has auto-package test. There's a test for LSB conformance. There's file system tests, real-time tests, network tests, security tests, and vertical testing. So why am I complaining about the status of open source testing if there's all these tests? This is really not working that well. Is it possible to get a replacement? Or, okay. Let me move on to test hardware while they're working on that. So there are off-the-shelf components for doing a lot of the lab, controlling the items in your lab. Power distribution units, there's a whole bunch of units for that. There are commercial boards, there are video capture boards, and I'm not going to go into the details of all of these. But there's also open hardware that's available. The Acme board by Bay Libre does USB management, SD card management, and power measurement. MuxPy by Samsung. Sony has a debug board that's open hardware. There's analyzers based on the SIGROC standard. And the lots of different labs are using this open hardware, and it's nice because a lot of it is fairly inexpensive. But each lab tends to use a combination of different things, and they often have to use still a lot of manual management that goes on in a lab. If you've ever had to run a testing lab, you know that's true. And there's still a lot of custom in-houses, particularly when you get to hardware testing. There's a whole lot of custom hardware solutions that are developed by companies for their individual things. So if you look at the overall status in the industry, in terms of QA efforts, there's a lot of in-house tests that are written, ad hoc tests, and there's still a lot of manual legacy testing. And the result of this is that you have all this stuff that's still unshared. And there's a lot of QA artifacts that are not even tangible. There's knowledge in the heads of QA developers that is not shared with between companies. And that's because there's no kind of object that it can be encapsulated in. So if you're developing a camera, a digital camera, what tests should you run to validate that software stack? What are the dependencies on that stack? How should I interpret the results? So everyone runs LTP. That's kind of my guinea pig that I like to talk about. Everybody runs LTP, and everybody knows that LTP will produce, out of 1,000 system call tests, about 50 will fail. And the question is, well, is that good, bad, do we care? What metrics are important as a test developer? And what I'd like to do is get to a point where we can actually share some of that, which I would call kind of the level above just running the test, but share the information associated with the test. And hardware testing, like I said, is extremely siloed. Now, there are some exceptions to this in terms of sharing. So when you have a single dominant platform by a single dominant vendor, something like Android, you have something like the CTS, the Compatibility Test Suite. And that is used by, I believe, almost every Android vendor. And so there are counterexamples to my thing here that things are all unshared. What I'd like to assert is that basically today's QA software, the state of the industry, is a lot like the RTOS world was about 20 years ago. If you look at the RTOS world about 20 years ago, it was horribly fragmented. There was a lot of in-house tests, a lot of ad hoc testing was, or not tests, sorry, a lot of in-house operating systems. When I signed up for Sony, I've been at Sony 15 years, and when I first joined Sony, they had a total of 26 operating systems across their product line. And that was after they had standardized on a couple internally. And so things have changed dramatically. Now we probably only have about 6. That's still a lot, but it's way less. And so you see a lot of this stuff is unshared. Now, there have been exceptions. There were real-time operating systems that were open source 20 years ago, but now we've seen a big consolidation around Linux and around some other operating systems. If you look at like the testing that goes on for a TV set, and I'll just pick on, I know that there are more TV set vendors than just these 3, but Samsung, LG, and Sony. I happen to have been involved with testing on TV sets at Sony. About 80% of the software stack on a TV set is open source. And so you would expect that maybe 80% of the QA software would be open source, but it's nowhere near that. I would say, you know, we run LTP and we run a couple other things, but most of the real critical testing is all unique in-house Sony stuff. And so which of these companies is contributing to open source test projects? And, you know, and I'll go on record, including Sony, hardly anybody. Nobody does it. And do we share our TV functionality tests? And so that's what I think is really crucial. I think we can do a lot better in terms of sharing stuff with each other. Okay. So what are the obstacles? Okay, so I didn't time this talk very well, and I have very little self-control on my end. So if there's a couple of slides in here that have these kind of keynote-y abstract principles on them. I'm going to slow down and talk about those. But for some of these slides, if they have words on them, I'm going to like breeze right past them, and you can get the slides off the sketch.org site. They're up there, but they're not the exact same version of it. I'll fix that this afternoon. because I had to put something in that my Uber driver told me. But obstacles. So silos. The biggest obstacle, I think, is that there's just too many testing silos. To paraphrase the philosopher Indiana Jones, why did it have to be silos? Really, if you look at the testing landscape, it's a tale of fragmentation and specialization. And it's worse than just having a bunch of silos where these different tests are taking place. It's that the silos are all different. And so we can't, it's really, really hard to get stuff interoperable between these different test frameworks. And so here's my list of the obstacles to sharing. And again, a lot of these are wordy slides, and I'm not going to go into them in great detail. But you have this fragmentation of the test hardware that I talked about. So even if you have, so there's lots of different PDUs that are available in the world. And PDU stands for Power Distribution Unit. So a thing that can basically turn your board on and off. You wouldn't think that there would be so many different ways to do that, but there are. And the different devices are controlled with serial commands, or they're controlled over the network, or they're controlled over USB. And so they have different APIs. So there's no single API in the test lab for just turning on and off the board. It's the most basic function that you can possibly imagine, and there's no consistent API. Or I'll come back to that, because there are people in the room who are probably going to argue with me on that. But in terms of lab configuration, I mentioned this before. Each lab mixes and matches their equipment. And so they have, each lab ends up with different unique combinations. So when a test is written for one particular lab, it's not portable to another lab. Now, there are projects that are working on that, and that's part of the effort that we're doing here, is to make it so that we can take tests and run them, take them from one lab and run them in another. Okay. Switch, okay. So, and then another area of fragmentation is the test framework itself. So, like I mentioned, there are about 10 or so open source test frameworks, and they cover kind of different things, but they have very, very different models. In particular, the two that I'm interested in here are Lava and Fuego, and they have just very, very different views. They have where is the test driven from? What's the life cycle of the target during the test? What languages are used? What are the APIs? The APIs are quite different for each one. And then the dependencies are quite different. So, so it's really difficult to take a test written for one test framework and use it in another test framework. And then, as I said before, in the case of like TV sets, you've got about 80% of the stack which you should have in common with another vendor, but you still have that stuff on top, and you have legacy layers in there and legacy test software. And so the vendors themselves, the people who are doing the testing to get a product out the door, have essentially different software stacks and different capabilities in that software stack. So even if two products happen to be based on, say, a Yocto project, well, you can customize, you can turn the knobs and dials on Yocto project and generate your own distribution of Linux, and you may not have some tool that the test system actually needs. A good example of this is expect. So in Fuego, we don't have any tests that use expect, because we don't expect to be on, well, anyway. Expect is one of those tools. It's got a PHP history, and so it's not always going to be on an embedded target. And then different testers, another area of fragmentation is different testers have different goals. So the goal of someone who's a kernel maintainer is quite different than the goal of a product in quality assurance engineer, right? So they're interested in different parts of the system, and dare I say, they have a different threshold of sensitivity to bugs. Kernel developers are much less lenient about bugs. In the case of an embedded system product in particular, I know you'll find this hard to believe, but people have shipped products with known bugs in them before. And there's a different focus on remediation, local remediation of some problem, doing a quick workaround versus upstream reporting and fixing. And so you see, because of those different testing goals, you see a lot of different fragmentation in the test implementations themselves. And then two last things on this area is organizational inertia. We've had a good 25 years for our software development teams to learn how to interact with the community, and we've had much less than that for our QA teams to learn how to interact in the community. And so my experience has been that, well, just speaking strictly from inside Sony, we're good at consuming open source components, but we're not very good at interacting with the community. And there's the same historical concern that's always been true with open source. Companies are concerned that testing will reveal the product information prematurely. That's also true just of the contribution to the open source itself. And so that's just, that's been true for a long time for all of open source. There's a really kind of interesting licensing issue, and this came up in a different context, but in the area of testing, so companies don't usually ship their test software, and so there's nothing that actually triggers, license-wise, a requirement to distribute the tests themselves, right? Because GPL or reciprocal licenses, usually that stuff is dependent on the distribution of the source code. Companies aren't distributing that source code, so that's an obstacle. So I painted, I don't know if that's a dire picture or not, but it is a picture of kind of the obstacles. But I think there are some solutions that we can go on. So I think, in a nutshell, I think we need to start creating objects that can be shared. I'll talk about a common CI reference model that a group of people has been working on, including folks from Linaro. Standardized test definitions, including common APIs and languages. An effort to standardize APIs to the lab hardware, and then some other stuff that I'm going to talk about, so I don't need to talk. So before I get to that, though, I want to talk about the software stack. So everybody's seen a diagram like this. Don't look at the details because they're unimportant, and this is a super old slide that I just grabbed out of one of my old things. Everybody's seen slides where they have layers of software talking to each other, and sometimes there's hardware in there as well. And I found this picture of a Jenga thing that looks kind of the same. It's got layers with these blocks that you can slide in and out, and it's even colored with the different colors. The problem with open source testing is this is not what the landscape looks like. It looks more like this. Okay, you've got Fuego and it's got some layers, and you've got Lava and it's got some layers, and you got Yocto and it's got some layers, and then you got crazy stuff. And what happens if you try to combine these? Well, you get stuff that's unstable and doesn't work, and so it's really important for us to work together to try and harmonize this stuff. So one of the things we did is we had a testing summit in November, and actually October it was, but we tried to come up with a common CI reference model. And this is what we have so far. This is by no means the what we intend to use forever, but this is our first pass at trying to come up with what are the major building blocks for a test stack, and where are the APIs? So each of those lines in that diagram is an API between two different parts of the system. And it turns out that this is actually not bad. We were able to get 4 or 5 different frameworks that kind of matched up with these boxes and these interfaces, not 100%. But so now we can start talking about like interface D, which is the interface between the build and test management software and the build artifact server. And we can say, well, if we have a known interface right there, well then it doesn't matter what we put on that repository server. We can plug and play there, and we can let those components actually develop, and the implementations can develop independently of each other. And that's actually really advantageous. We want to create shareable objects. We want to create test definitions that are usable in multiple frameworks, shareable pass criteria, shareable results, a common result format. And so the gold standard for modularity is Lego bricks, right? So everybody knows about Lego bricks. In fact, if I was to do a poll, I would bet that almost all of you have played with Lego bricks at one point or another. So there's another product also produced by the same company called Techniques, which the pieces are a little bit more specialized, okay? And then you see this pirate thing here on the far right, which has very highly specialized pieces. And if you try to mix and match these, it's not going to work. It's the same thing as with those stackable blocks I was talking about. You've got to create objects that you can share and that can actually interact with each other. So one of the things we want to do is actually talk about the test definitions. And that's a very specific thing. The definition of a test is the metadata and instructions for running a test. It consists of a whole bunch of different elements. I've got a whole presentation on that later today where I go into laborious detail, more than you want to hear about here. We want to define standards for the lab environment, the same thing. We want for the board control, for multi-machine tests, for the external hardware. We want to define APIs for each of those elements that are in the lab thing. If you remember back to the reference diagram, there was a whole big box that did not have arrows inside it because we figured that there were probably at least 100 APIs in there that need to be spec'd out. But the end goal is to create an ecosystem of plug-and-play modules. And we want to create a place to share modules. Right now, everybody is storing their test artifacts or their test materials inside their own Git repositories. And if we're going to do something that's cross-framework, we need to have a common place where we can share stuff. And there's a whole bunch of issues associated with that. Again, I'm going to skip over some of this stuff. So tests, in order for tests to be reused between companies and between test frameworks, they have to be generalized so they can handle kind of the differences in the way people are working. But in order to be actually useful, they have to be customizable. So there's this real tension between the specialization and the generalization of the tests. And we have some ideas of what are the things that you can do to take an existing test and customize it for a particular environment while still leaving it as general purpose so we can work on it together. And so some of these are actually things that we've done to LTP in the last year. We added skip lists, LTP. We're talking with Linaro and folks here about harmonizing our test variables, which are kind of the set of the command line options to the different subtests. And so there's a lot, and coming up with workload files. Anyway, so we'd like to generalize versus specialize. Oh, and I got to be careful here on my time. So unfortunately, I've got a great analogy here. Well, I'll do it in 20 seconds. Okay, so if you take these two toys, these two sets of pieces, and you try to build a skeleton, obviously the one on the right is better for building a skeleton. But the one on the left, you can make a passable skeleton, right, with Lego blocks. Now, what happens if you try to take these two sets of pieces and build a house or a car or a boat? And the answer is that you can make all of those with Legos. In no case are the Legos like the best possible solution, but you can use the same components to build all of it. And so a generalized block it turns out to be much more effective to cover the range of things that you want to do than these specialized blocks. Okay, so that's my pirate man analogy. And so the basic idea is that we want to take the test components that we have now, we want to take our pirate pieces and we want to turn them into Legos, or at least make them compatible so we can put the Legos together. It turns out that you can take a set of Lego blocks and make a Raspberry Pi case. You cannot do the same thing with pirate pieces, or at least not. Well, it would be interesting. I guess it would be a very custom pirate case. So what are the next steps? The title of my presentation said next steps, and I've got 2 minutes to do it. I'm going to go through these super fast. Basically, we want to keep working on standards. At the Automated Testing Summer, we actually agreed. The one thing we came to agreement on was that we were going to use PDU daemon, which is a project that was started by Linaro, as our PDU layer. And so that's our first lab API to be standardized. We're working on standardizing other things like the test definition, the results definition, the backend API. We're currently looking at kernel CI and Squad. We added support for both of those to Fuego in the last year. But we need to do a lot more interchange. So we did a test stack survey. We surveyed, I think, 24 different test stacks and looked at the different components, tried to compare them with each other. Those results are all online in the eLinux wiki. And we want to start actually prototyping cross-using components. We won't find out where the problems are until we actually start doing it. So what we want to do is we want to use, we want inside Fuego, we want to use Linaro tests, and we'd like to see how we can, inside Lava, use Fuego tests. And that'll reveal a lot about the pain points and about where the kind of the rough edges are. We have meetings this week, and we're going to have more meetings. We're currently planning Automated Testing Summit #2. There's probably going to be something going on, a Plumbers Micro Conference, and I wouldn't doubt that we'll end up with both of those. So now to my Uber driver. As I got ready to go to the airport, so I took an Uber to the airport in San Jose on Sunday morning. And as happens occasionally in Silicon Valley, I ended up driving with a retired 30-year veteran of quality assurance and open source, in technology testing. Well, not open source. He worked for Sun, and I think he worked for Adobe. But we had this great chat about stuff. And the conversation was far and wide, but we ended up talking about, of course, lunar landings and China isolationism, technological isolationism. Okay, so you can have it's a long ways to the airport. But one of the things that stuck out in my mind as we were talking and just having a nice conversation is he said, yeah, you know, China, because they had this isolationist policy in their early history, they were kind of behind technologically at the beginning of the 20th century. But they reversed that policy, and now China leads in a lot of areas. And in fact, it's now there's a fear. I don't want to introduce any kind of political notion in here, but you know, there's Americans who are like, hey, what are the Chinese are getting ahead of us? And so the moral of the story is isolationism is bad. It puts you behind. But it doesn't take much. If you change the principles involved, if you convert to a sharing and an interchange economy, you can catch up pretty fast. And I think that's what China has demonstrated. My vision for open source testing is I want to do for testing what open source has already done for coding. So Linux is now the #1 operating system in the world in terms of deployed use. And I want to see a collection of open source materials that are also the #1 way that software is tested in the world. And we do that by promoting the sharing and automated CI components, artifacts, results, just the way we share code now. If you don't get anything else out of my talk, here's the too long, did not read. Being open source is not enough. We have to fight fragmentation. We have to work together to unfragment this open source testing landscape. We have to generalize, and we have to get rid of those silos. And with that, I think I have a slide on my image sources. You can check that out. But thank you for your time. So.
Thank you so much, Tim. Really great stuff. OK, so that wraps it for this morning.